Hello, welcome to another video in solving fluid mechanics problem. For today's video, we're gonna solve for relative equilibrium of liquids. So our sample problem goes like this. A cubical tank is filled with 2 meters of oil having specific gravity of 0.8. Find the force acting on one side of the tank when the acceleration is 5 meters per second squared, A vertically upward and B vertically downward. So first, we're gonna identify the given. We have a specific gravity of 0.8. We have the height of the center of gravity and the cubical tank that has a measurement of 2 by 2 by 2. And our assumptions are upward direction is positive and downward direction is negative. Required in the problem are force acting on one side of the tank when the acceleration is 5 meters per second squared, vertically upward, and vertically downward. So first, we're gonna solve the force acting on the tank in vertically upward direction. So the formula we're going to use is the hydrostatic force is equal to the pressure in the center of gravity multiplied by the area. Since we're looking for the vertical motion, we're gonna use the formula force is equal to unit weight multiplied by the height center of gravity multiplied by the sum of 1 added to the acceleration over gravity multiplied by the area. We just have to substitute the value and we now have 9.81 kilonewton per cubic meter multiplied by 0.8 multiplied by the height of the center of gravity multiplied by the sum of 1 plus 5 meter per second squared all over 9.81 meter per second squared multiplied by the area, which is 2 meter raised to 2. We cancel the meter, second square unit, and meter unit, giving us 11.848 kilonewton per square meter multiplied by 4 square meter. We're gonna cancel out the square meter unit, leaving us with a final answer of 47.392 kilonewton. Finally, we're gonna solve for the vertical motion with a downward direction. Same as the first problem, we're gonna use the formula F is equal to the unit weight multiplied by the height center of gravity multiplied by 1. Since it's downward, we're gonna use negative, so it's gonna be 1 minus 5 meter per second squared all over 9.81 meter per second squared multiplied by 2 meter raised to 2. We just have to substitute the value and we now have 9.81 kilonewton cubic meter multiplied by 0.8 multiplied by the height of the center of gravity multiplied by 1 minus 5 meter per second squared all over 9.81 meter second squared multiplied by the area, which is 2 meter raised to 2. We cancel the meter per second squared unit and meter unit, giving us 3.848 kilonewtons square meter multiplied by 4 square meter. We're gonna cancel out the square meter unit, leaving us with a final answer of 15.393 kilonewton. That's all for today. Thank you for watching.